manufacturer produces two types of batteries, type A and type B. To compare the mean lifetime of the two types of batteries, a sample of 25 type A batteries was selected and had an average lifetime of 90 hours with a standard deviation of 8 hours. Another sample of 30 type B batteries was selected and had an average lifetime of 85 hours with a standard deviation of 7 hours. Construct a 95% confidence interval for the difference in the mean lifetimes of the two types of batteries. Okay, so let's get started by identifying all of the key pieces of information that we have in the problem. So we have type A and type B batteries, and a sample of type A batteries was 25, so that's our N1. The average lifetime was 90 hours. That's our sample mean, or X sub 1 with a bar on top of it, with a standard deviation of 8 hours. So this is our S sub 1. Another sample of 30 type B batteries, so that's our second N value, or N sub 2. It was selected and it had an average lifetime of 85 hours. That's going to be our X sub 2 with a bar for our mean, and the standard deviation of 7 hours. So this is our S sub 2. And we have to construct a 95% confidence interval. So in order to find the lower and upper bounds of our confidence interval, we're going to be using the formula sample mean for set 1 minus the sample mean of set 2 plus or minus t star times the square root of S sub 1 squared over N sub 1 plus our standard deviation for set 2, S sub 2 squared, over the sample size for set 2. Okay, now so far we have just about all of these values, and we'll fill them in. We know that X sub 1 is 90, X sub 2 is 85, plus or minus, we don't know T star yet, so I'm just going to draw a blank space. And I have the square root, S sub 1 is 8 squared over our N sub 1 value of 25, plus S sub 2, which is 7 squared over our N sub 2, which is 30. Okay, so now we've got to calculate our T star value. And in order to do that, we need to determine the degrees of freedom. The degrees of freedom is equal to N sub 1 plus N sub 2 minus 2, or the sum of our two sample sizes minus 2, because when we have one sample, it was just N minus 1. So if we do N minus 1 for set 1 plus N minus 1 for set 2, when we combine like terms, we get N for set 1 plus N for set 2, and then minus 2. So we would have 25 plus 30 minus 2, and that's going to be 55 minus 2, which is 53. So the degrees of freedom is 53. We need that, as well as our significance level. So our significance level, because we want a 95% confidence interval, the significance level would be, it's going to be 5/100ths. So we can put those values into an online resource and then press the calculate button. And when we press the calculate button, we get that the two-tail t value to be about 2 6/1000ths. So I'll fill that in here. And now we can substitute these values into a calculator. And I put it into the calculator first with the plus sign, and I end up getting about 9 11/100ths, because all these decimals are rounded to the nearest hundredths place. And if I substitute it in and evaluate it for the subtraction sign, I get about 89/100ths. So the correct answer here for this problem is answer choice B.